Hello and welcome to this session. Learning Outcome, LO4, understand the theory and reactions of acids and bases. Today, we will explore how acids and bases interact in solutions. Have you ever wondered what happens when an acid reacts with a base? This lesson introduces the fundamental theories of acid-base chemistry, from Arrhenius to Lewis. Let's dive into the world of chemical reactions and their applications. Arrhenius theory is one of the earliest explanations of acids and bases. An Arrhenius acid produces hydrogen ions in aqueous solutions. Conversely, an Arrhenius base yields hydroxide ions. For example, hydrochloric acid dissociates into hydrogen and chloride ions. This theory is limited to aqueous solutions. The Brønsted-Lowry theory is widely used in chemistry. It defines acids as proton donors and bases as proton acceptors. In a reaction, hydrochloric acid donates a proton to water, forming hydronium ions. Ammonia accepts a proton from water, forming ammonium ions. This theory introduces the concept of conjugate acid-base pairs. Conjugate acid-base pairs are central to Brønsted-Lowry theory. When an acid donates a proton, it becomes a conjugate base. Similarly, a base accepting a proton becomes a conjugate acid. These pairs differ by a single proton. Understanding these pairs helps in predicting reaction outcomes. Lewis theory expands on acid-base reactions beyond protons. A Lewis acid is an electron pair acceptor. Conversely, a Lewis base is an electron pair donor. This theory explains reactions that do not involve protons. For example, boron trifluoride reacts with ammonia in a Lewis acid-base interaction. Neutralization is a common acid-base reaction. It involves an acid reacting with a base to form salt and water. For instance, hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. This reaction is exothermic and forms a neutral solution. Neutralization is widely used in various applications. Acids react with metals to form salt and hydrogen gas. The general reaction involves an acid and a metal producing salt and hydrogen. Magnesium reacting with hydrochloric acid forms magnesium chloride and hydrogen gas. The reaction speed depends on the metal's reactivity. Hydrogen gas can be identified by a squeaky pop with a lit splint. Acids react with carbonates to produce salt, water, and carbon dioxide. The reaction involves an acid and a carbonate. For example, calcium carbonate reacts with hydrochloric acid to form calcium chloride, water, and carbon dioxide. Carbon dioxide turns lime water cloudy. This reaction is essential in geological and industrial processes. The pH scale measures a solution's acidity or alkalinity. It is based on the concentration of hydrogen ions. A pH of 7 is neutral, less than 7 is acidic, and greater than 7 is alkaline. The scale is logarithmic, meaning each unit change represents a 10-fold change in hydrogen ion concentration. pH is crucial in various scientific fields. Please take the time to read this information carefully. pH measures acidity, not concentration. A dilute strong acid can have a higher pH than a concentrated weak acid. Strength depends on the degree of ionization, not the amount present. Understanding this distinction is crucial in chemistry. It helps predict reaction outcomes and control processes. Acid-base reactions involve the transfer of protons. They form the basis for many chemical processes. Understanding these reactions helps in predicting outcomes. It is essential in fields like pharmaceuticals and environmental science. These reactions are foundational in chemistry. Acid-base chemistry is applied in various industries. It is crucial in pharmaceuticals for drug formulation. Environmental science uses it to manage pollution. In agriculture, it helps in soil pH management. Understanding these applications showcases the importance of acid-base chemistry. Safety is paramount in acid-base experiments. Always wear protective gear like goggles and gloves. Handle acids and bases with care to prevent accidents. Proper ventilation is essential to avoid inhaling fumes. Following safety protocols ensures a safe laboratory environment. The understanding of acids and bases has evolved over time. From Arrhenius to Lewis, each theory added depth. This evolution reflects the growing complexity of chemistry. Historical context helps appreciate the current understanding. It highlights the scientific journey of discovery. Key concepts include understanding acid-base theories. Recognizing conjugate pairs and proton transfer is crucial. The pH scale measures acidity and alkalinity. Neutralization forms salt and water. Mastering these concepts aids in exam success. Misunderstandings in acid-base chemistry are common. One misconception is confusing strength with concentration. Another is misinterpreting the pH scale. Clarifying these helps in better comprehension. Addressing misconceptions improves learning outcomes. Practical applications of acid-base chemistry are vast. They range from household cleaning to industrial processes. Understanding these applications highlights chemistry's relevance. It shows how theory translates into real-world use. Practical knowledge enhances theoretical understanding. For further learning, consult textbooks and online resources. Silberberg's and Atkins books are excellent references. Online platforms offer interactive learning experiences. Engaging with these resources deepens understanding. Continuous learning is key in the field of chemistry. Assignments reinforce understanding of acid-base chemistry. Follow the guidelines provided for submission. Ensure clarity and accuracy in your responses. Submit assignments on time to meet deadlines. They are an integral part of the learning process. In conclusion, acid-base chemistry is fundamental in science. Understanding its theories, reactions, and real-world applications is crucial. This knowledge provides a strong foundation for further exploration in chemistry and its many practical applications. If you have any questions, please feel free to contact us via WhatsApp at 0748-436-1688. We look forward to seeing you at the next session. Thank you for your attention.